Okay, let's go through this example and just know that logarithms are inverses of exponents because in this situation, we're going to be looking for the exponent. So we're going to be solving for that exponent. It says in 2015, the US population was 192 million and was growing at a rate of 0.4% each year. We're going to write an exponential growth model to see what year that the population is going to reach 350 million. So we're going to have y equals ab to the x. Y is our total. So our total, we want to know when we reach 350 million, our initial population is 192 million. And our growth factor is 1 plus 0.004, so 1.004 raised to the x. So we want to know in what year are we going to have 350 million. So once we find out the number of years, we will add that, once we round up, we'll add that to year 2015. So the first thing we can do to isolate x is we will divide both sides by 192. So we have 350 divided by 192. So that's the total divided by the initial amount. And we have 1.004 raised to the x. Now the inverse, or how we can get this x out of the exponent, is we're going to bring the x out and x times the log of 1.004. And since we took the log of the right side, we have to take the log of the left side to keep it balanced. Now we need to isolate x, so we're going to divide both sides by log 1.004. And then now we have isolated x. So x equals log of 350 divided by 192, all divided by log of our base, our growth factor, 1.004. Now, I would bring up my calculator, but apparently it is not installed on my computer, so they won't get that. So let me just show you on this image. Here we have the log button. So I would use n over d. So in the calculator, I would do n over d. And then we're also going to use n over d again. So we'll have n over d. So log, and then we had, let's see what it was, 350 divided by 192. So log, and then in your denominator, log of 1.004. So you're going to use n over d twice. You're going to use it for having these numerator denominator, but then in here I would use numerator over denominator n over d again. And then that is going to give us, and I'm going to do it with my handheld calculator. So let me get to that. So I have n over d and then log, and then I'm going to do n over d again, 350 divided by 192. And then in my denominator, log and 1.004. And when I click enter, hold on, that just cleared it, sorry. So do that one more time. Now click enter, I get 150.4 and so on, but let me take you back because it says round to the nearest year. So what I got in the calculator was x equals 150.409, yada, yada, yada. So I'm going to round x, I'm going to round it up to 151. So in 151 years from 2015, it will be 350 million at this growth rate. So I'm going to add 151 years to 2015. and this should be the year. So what I'm going to do now is I am going to just write the formula for us. Okay, so here is our formula. The total population equals our initial amount times our growth factor, which is 1 plus the rate, raised to the x. To find x, the formula is x equals. We're going to have log of the total divided by the initial, all divided by the log of our base, which is the growth factor. Okay, I'm just going to call it B. That is growth factor, which is 1 plus your rate. And remember, the rate is a decimal, so this is a percentage. So to write it as a decimal, we move it 2 places to the left, so 0.004, and then when we added the 1, that's how we got, this is our growth factor. Okay, I hope this helps, Sloan.